Okay, question 4. This is talking about a cylinder. So let's just do a quick sketch of a cylinder. And the radius is r. There's no mention of the height here, so let's just call it h. And we're told that the volume is 250 pi centimeters cubed. But we also know the volume of a cylinder is the area of the surface at the top, the cross section, which is pi r squared times the height h. So we know the volumes of that. Now the question is also talking about the surface area S. So if you think about the surface area, if you've not done the volume of the surface area of a cylinder for a while, remember it's just a rectangle. If you were to unfold the middle section, the curved section, that would be a rectangle, and then you got the two circles for the top and the bottom. So the middle section has a height h, this rectangle, and the length of this will be the circumference of that circle at the top. So that the circumference of a circle will be 2 pi r. So the curved surface area of the cylinder is 2 pi r h, and obviously this is pi r squared, this is pi r squared. So the total surface area, is given by the total here. So it's 2 pi r h plus 2 of these, so 2 pi r squared. Now you can see in the question there are no h's, so we need to end up with a formula with no h's in. So in order to eliminate h, we can use the fact that these two are equal. So we can write pi r squared h equals 250 pi, and then the pi's are going to cancel here, and so h is going to equal 250 over r squared. So that means we can replace the h down here. This h can be replaced by 250 over r squared. So if we do that, we're going to get s equals 2 pi r 250 over r squared plus 2 pi r squared. And you can see that this r is going to cancel with one of these, and 2 times by 250 is going to give us 500. So if we do that, we will get what we've got up here. I think we'll have 2 pi r squared. So this 2 pi r squared, we will have 2 pi r squared, and this all simplifies to give us 500 pi over r, which is what we're asked to do in part A of this question. So part B, or part 2, it says given that r can vary, find the stationary value of s. That just means find the stationary point, really. So in part 2, the stationary point is when the gradient equals 0. So we've got to find ds by dr, put that equal to 0, and solve it. So let's do that. So that using the equation above, we've got 2 pi r squared plus 500 pi. Let's bring the r up to make it r to the minus 1. Makes it easier to differentiate. So differentiating, we're going to get 4 pi r, and then minus 500 pi r to the minus 2. I think it's easier to work with if we make that we make that plus r squared on the bottom. And don't forget, we're trying to solve this. We're trying to find the stationary points. We need to make ds by dr equal to 0. Now to solve this, let's multiply everything by r squared. So we get 0 equals 4 pi r cubed, whoops, sorry, minus 500 pi. All the pi's can cancel. And so we just want to rearrange this, get r on its own. So if we do that, we're gonna, let's put the 500 over on the left. Divide by 4, that will give us 125 equals r cubed. And so r will equal 5. That's not the answer to the question though. The question says, let's just go back to what the question says. It says find the stationary value of s. So not the r value, it's the value of s we actually want. So we now need to substitute this back into the original equation here for s. So if we do that, s equals 2 pi 5 squared plus 500 pi all over 5. So what's that? 25 times 2, so that's 50 pi plus 100 pi. So that is 150 pi is the answer to part 2. And then the final part to this question, so part 3, let's just have a look what that says. It says determine the nature of this stationary value. Okay, so we need to know if that's a maximum or a minimum point for this cylinder. So as usual with stationary points, we want to find the second derivative to identify their nature. So we're differentiating this equation up here. We're differentiating ds by dr. So if we do that, we're going to get 4 pi, and then that's going to be plus 1000 pi r to the minus 3. So let's just simplify that a bit. Let's just write that with the r cubed on the bottom there. And we know that r equals 5 from our previous question, so we know that r equals 5, and we want to know if there's a maximum or minimum when r equals 5. So when r equals 5, the second derivative, which we've just worked out, will be 4 pi plus 1000 pi over 5 cubed. So that's 4 pi plus 1. So 5 cubed is 125. 1000 divided by that is 8. So that is going to equal 12 pi, which is definitely going to be a positive number. So 12 pi is positive. Okay, so this is positive. So I would say positive value for the second derivative. So I would say therefore this will be a minimum. There will be a minimum value. This is a minimum value at r equals 5. You could put in brackets s is when s is 150 pi, but the important thing is this is going to be a minimum value